We are only a little way into the 21st century, but signs of a warming planet are already evident around the globe: more frequent droughts in East Africa, stranded polar bears in the Arctic, bleached coral reefs in the tropics, and retreating glaciers in the high latitudes. Along the coasts, sea levels are rising. Even so, a new study really surprised me. By burning huge quantities of fossil fuels, we humans have tipped the Earth off its axis by a tiny amount. Let me emphasize how tiny the tipping is. Each year since 2005, we have shifted the spin axis from its previous path by centimeters, not kilometers. The north-south spin axis of the Earth runs through the North Geographical Pole in the Arctic Ocean, and the South Geographical Pole in the Antarctic. I'm not talking about the North and South magnetic poles, just the geographical poles. But as the Earth spins on its own axis, the position of the North Pole is not dead true, it wobbles a little, for several reasons. For one, the Earth is not perfectly spherical. Instead, it's a bit flattened at the poles, and a bit bulging at the equator. And the surface is not smooth, it's pretty bumpy. Mountains poke up towards space, while oceans dip down into the solid crust. Our planet is not perfectly rigid, either. It's somewhat elastic. Yes, it does have a solid crust at the surface, but it's very thin. Earth is made mostly of molten rock and then liquid iron, with a core of solid iron. So even today, parts of the crust that carried heavy ice sheets 20,000 years ago are still slowly rising, an effect known as the isostatic rebound or post-glacial rebound. As a result of these, and other, factors, when Earth rotates on its own axis over the course of a day, that spin axis wobbles a little. There are lots of individual wobbles. A major one is the so-called Chandler wobble, which American astronomer Seth Carlo Chandler discovered in 1891. During a period of slightly more than a year, about 433 days, the Chandler wobble shifts the North Pole over a rough circle or ellipse about several meters across. About 2/3 of the Chandler wobble seems to be caused by ocean currents, and about 1/3 by winds in the Earth's atmosphere. It's hard to imagine something as small as we humans being able to shift something as massive as our whole planet. From 1982 to 2005, scientists found that the North Pole was drifting slowly south towards Labrador, about 6 to 7 centimeters each year. But in 2005, the motions of the North Pole suddenly flipped in 3 unexpected ways. First, the North Pole chucked a lefty and started heading east, parallel to the equator. It's still heading east. Second, the North Pole more than tripled its drift speed to about 24 or so centimeters per year. It's still drifting at this speed. Third, the Chandler wobble changed phase, and so far, scientists have no explanation for why. But they do have a good answer for the tipping of the spin axis. Rapid melting of ice on land has made the drift velocity of the North Pole accelerate, and has changed its direction of travel to the east. This solid ice is now liquid water spread across the planet. We know where the ice was, we know where it's gone, and the maths all fit with the observed changes to motions of the North Pole. Since the mid-1900s, we've used satellites to accurately measure these land ice changes many tens of millions of times. Recent analysis shows that between 2011 and 2014, Greenland, Antarctica and mountain glaciers were losing about 600 billion tons of ice per year. Most of the ice came from Greenland. This was an increase of 2 to 3 times the loss rate between 2003 and 2009. It's hard to imagine something as small as we humans being able to shift something as massive as our whole planet. But we used global warming as a force multiplier. We dumped billions of tons of carbon dioxide into the atmosphere, heating it along with the oceans. The combination of hotter atmosphere and ocean water then melted over 500 billion tons of ice, which flowed into the oceans. This redistribution of water shifted the north-south spin axis. Why did both the Chandler wobble and the spin axis shift suddenly, instead of gradually? We don't know yet. Perhaps it's like slowly pushing a pencil towards the edge of a table. You push and you push and you push, and it's still on the table. But then you give it just one more tiny push. The table no longer supports its center of gravity, and it suddenly falls to the floor. So if we push and push at the balance of our planet, it may well respond by throwing a real wobbly of its own.